That's great when I say something and I look at all your faces and y'all look like you want to kill me right after a joke. That's awesome. Just inspiring. So feel free to tell that at the dinner table with your parents or guardians. You'll get a laugh just like I did. All right. So we're on the whole here. We're actually factoring this number 4. Sorry for starting the movie late for anyone that's watching. Nobody. And then, so now that I find out that 0 is a bad value because these x's cancel 0, comma, I plug in 0. And come on, when you plug in 0, 0 plus 3 is 3. 0 minus 2 is -2. -4 is -4. 0 minus 1 is -1. This is the evaluation of plugging in 0 into this blue equation. You get -6/4, and that becomes -3/2. And then you go to the graph and go -3/2 down here. All right, you got to remember that that's the hole there, because then when we go to the graph, we start trying to connect dots. Oh, right, that hole's there. So it should be the first thing that I mark down there. All right. Now, again, I really do appreciate calling your numbers in class and making you answer questions. I know you hate it. I don't care. Wait, was the answer to the joke? Wait, what was? Oh, so what's the best time to go to the dentist? 2:30. So 2:30 is the time, but tooth hurty. My tooth hurts. Never mind. Okay. So I appreciate the asking that joke again because I bet you do want to tell it. All right. Okay, so now back to this. How do you get an x-intercept? You plug in 0 for y and solve for x. Okay, so x plus 3, x minus 2, going to go over this one more time, over denominator. Then the first thing you're going to do is multiply both sides by the denominator, and then 0 times the denominator is still 0. So ultimately, you end up with the numerator equal to 0 for x-intercepts and get -3, comma 0 and 2, comma 0. Okay, got to breathe when I'm teaching. When you have a mask on. 2, 0. Okay, so I want to mark those as I go. What is the y-intercept? Oh, we already have a hole on the y-intercept. And anyway, if I plugged in 0 for x, I'd get 0 over 0, which is undefined. Either way you look at it, there is none. So we're good with that. Okay, vertical asymptote. That's zeros of the denominator. Sorry. Oh, I guess I'm looking at this. Okay, so that's where I can glean my information from. Use a fancy word there. Zeros of the denominator because the denominator cannot equal 0. So if I plugged in 1 for x, blah, 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 undefined, that's why the graph behaves weirdly at x equals 1, this vertical line. Right, so we'll draw that. Okay, now is the time to look at this numerator compared to the denominator for a horizontal asymptote. Oh no, the numerator is bigger than the denominator. If I plug in 1,000,000, I get 1,000,000 cubed over -4 times 1,000,000 squared. This is way more powerful. When I plug in big numbers, the y's start going crazy. They don't conform or start approaching a specific y value. They either go off to a negative or positive infinity. All right, so let's go to the cheat sheets. I think I referenced this already. It's my 3rd time doing this lesson. Hey, at least I don't have to do it 6 times. That's nice. And it's on our calendar. Ooh, bogging down here. Look at all these windows open here. All right, and then here it is. So look, if n is greater than m, if the numerator's degree is bigger than the denominator, you got to know horizontal asymptote. What you have is what really should be called an oblique asymptote. Can everyone say oblique? I saw like 2 people's lips move. All right. So what you do is you physically divide and see what the quotient is of that division statement, and that is how the graph will behave. The graph will behave to this equation that's set equal to y to make it a graph. So I will show you as I move my fat face out of the way over here. All right. So get rid of that work, and we're going to do this work. Let me make sure I see this. So in the garage, In the garage, we put x cubed. Oh, it's like a sauna in here. It's like 99 degrees in here, just like yesterday. I think they're trying to kill me. Sweat me out of here. Sitting here sweating like a pig. I'm sorry. I'll just keep that to myself. So uncomfortable though. Physically divide these two, and then let's look up at what's in the numerator. Now, I've yelled at 5th and 6th hour about this. This is not like, this is unfair. How can he ask me this question? How can he dare think I can figure out what times this equals this? And it's a grade school question. I don't know if Lexi Samuelis could quite get this one, but she'd give it a try. Could you put it in the chat? What times negative 4x squared equals 1x cubed? We just need fractional thoughts. That's all we need. So what times negative 4 equals 1? And that would be is what I would put up here. Certainly going to be an x term. It's going to be right here. Nobody? Well, everyone's afraid. I don't want to put it on there and be wrong. Nope, need a little bit more. Night. Well, okay, John, yes. Ooh, you just missed on the good Emily. You put it in decimal form, although I like fractions. It's actually negative 1/4. And I prefer the negative 1/4 because this is going to be linear and we want a slope, analysis on this. Good. All right. So we distribute that. Sure, negative 1/4 times 4 is 1. And then x cubed. Just makes me sad, fractions. It's not just you, though. It's the history of my teaching. Students coming in to CAT as a senior are horrendous at fractions. And I don't get it. I don't understand. This has been for years. Gone. And then 2x squared. Now that I have kids, I'm like, Jesus, they're doing it in 3rd grade and 4th grade. Okay, anyway. Chat again. What times negative 4x squared, probably going to be the same people, equals 2x squared? Fraction form, please. I'm glad. Thanks for the 5 people that actually, put stuff in there. Emily again. Nice, Emily. You went to the fraction now instead of the decimal. Oh, no. Yes. Are these allowed? I'm just kidding. Just kidding. No, I'm kidding. This is what me multiplying, me taking this and multiplying it and then putting the answer there. So I'll do it again. Real quick. That was why we had to analyze that. It won't take me that long. So negative 1/4 x times negative 4x squared is 1x cubed. And that's what we wanted, like the division algorithm. But then this is minus x squared. This came from negative 1/4 x times 4x. But then we subtract. So that's why these turned into blue signs. And that's where this keeps the ball rolling here. Right. And then we said negative 1/2. Nice. We get a whole bunch. And it's not x. No x. No x. Because negative 1/2 times negative 4x squared is positive 2x squared. No x needed. So still much appreciated how many people throw themselves out there. That's good. Negative 1/2 times 4x is negative 2x. Choose a color, maybe flip it back to red just to show that you subtract, which means you distribute. You're gone. Negative 4x. All right. Now, at this point, hopefully you know in these kind of questions, this is the remainder. I'll tell you what happens in a slant asymptote, though. I won't mark you wrong. But I will say for slant asymptotes, they count this part meaningless. It's because this is what happens at the ends of the graph. The ends behave to this line. At the ends, when we're plugging in large numbers, this part essentially turns into 0, nothing. So what they do is they lop that off and not write that for what the equation of the slant asymptote is. Y equals negative 1/4 x minus a half. If you had to write out what's the slant asymptote and you put the remainder in there, I'd be fine. It's okay. It's okay. All right. But that's the theory behind this. We're talking about what happens at the ends. At the ends, that becomes meaningless. Okay. So what have I drawn? I got everything in there. So now I'm going to put that slant asymptote. Yes, a senior should know how to graph a line. Y equals negative 1/4 x minus a half. 0, comma, negative a half is the y-intercept. Drop 1, run 4. It is a line that's decreasing in value as you draw it. You know what? I'm ready to graph this. Because look at this. I got this point and this hole, which should have been a point, but it isn't because it can't be plugged in the original, but the new one. And then behavior to the asymptotes. Okay, gotcha. And then look at this. Oh, well, this point's sitting here, so I bet you this behaves this way to this asymptote and this way to that one. Oh, I guess I could use losing some weight with this heat situation. Okay, so hey, I'm going to show you a thing with the calculator. I got this ready. Whoops. See how my equal signs are turned off? And now I'm going to go and turn those on. So if you ever wanted to like save your favorites, but keep some other ones here, but not see their graphs, you can turn them off. Don't worry about where those other two come from. So another feature for all graphing calculators. It's only going to graph y1 and y2. y1 is our original function. y2 is the slope. I'm sorry, the slant asymptote. Watch what happens. Oh no, never mind. Don't look. Don't look. Close your eyes. Close your eyes. I have to wait. Close your eyes. Zoom standard. I forgot for that other one I changed. There we go. I'm going to zoom this back and then see the picture here and see that move. Hey, look at my NASA shirt. NASA found water on the moon where it should not be. It was a story Monday. It's like in little middle parts in craters, which is a fascinating discovery. Just revealed Monday. So they think they can put like places on the moon for astronauts to live for a while because of that. That'll be fun. That's depicted in the movie 2001: A Space Odyssey, which I always think about that movie. Realistically, that was 19 years ago. That's how far we're behind compared to that movie. Anyway, random thoughts by Mr. Samuelus. Hey, you see that? So it's perfectly approaching this red line, but not crossing. That's what we have right here. All right. So it really does emulate what's going on there with that. Okay, so done with this one. Hopefully you understand what a slant asymptote is. I did do this with the other class though. 6th hour. Oh, it must be gone. Maybe I put it here. Maybe I put it here. I think it's down there. No. Where is it? Oh, son of a nutcracker. I guess I got to do it all over again. I think what I did is I made up one. What if you had this? Oh, shucks. I don't remember. Oh, I got it. What I did with them is said, hey, what if you had something like this? Let me try to remember this. I know what I could do. The old screenshot. Boom. What I did is I said, hey, what if you had just this kind of situation? Because otherwise my brain won't be able to remember what that is. Paste. Okay, same idea. We have, sorry, that's a drag screen right there, but that says y equals. Numerator's degree is just a little bit bigger than the denominator. There's a vertical asymptote at x equals -4, but there's going to be a slant asymptote. Look at its factor. It's actually linear. So instead of long dividing, you could take this one and short divide it. No, I'm just kidding. It's synthetic division, which is shorter. Just remember how to analyze the answer. Okay, remember the remainder is meaningless in a slant asymptote. Remember, synthetic division depresses this polynomial. Aw. Remember, for slant asymptotes, fine, you can write it, but this part is irrelevant for what is the slant asymptote for this graph. And then I went to the graphing calculator and graphed that and showed that 2x minus 9 is the end behavior of this particular situation that I just made up. Okay, so where did I get this from? 6 hour, I really quick scratched this down. Don't go anywhere. Okay, I know what I have to do for zooming because of the last class. I got to change my window a little bit to see all the graphs. And you'd trial and error this if you were good with your calculator. I'm going to go to like -50, I think will do it. Really terrified, I hope it does. 50. This will skew the line a little bit as far as how the slope looks. Booyah. See down there? So there's one part. There's the other. Look at how it's like curved at the end. And then there's the y equals 2x minus 9 slant asymptote. Ooh, nice color. All right. Okay, so the whole idea today was slant asymptotes and knowing they exist. It really should be called oblique asymptotes. The reason is if the numerator was bigger by 2 degrees, then it would end parabolic, like an x squared. If the numerator's degree was 3 times bigger than the denominator, then it would end cubically, like this. Wait, like this. I don't know which way you see me. Who cares? We won't do that. Maybe in college. See yous. If you have any questions, feel free to stick around. Oh, I got to end the movie. What a good one.